Hello, this is Ira again. So today we are actually moving on into sensors and detectors. That is gonna be the subject 182.002. We are done with valves, and we're gonna start right on to knowledge K1.02. So sometimes what happens is that the NRC reviews the GFEs information and the GFEs content, and they update or get rid of information. So yeah, that's one of the things that we will see. There are gonna be some knowledge that they're not gonna be there, and that's okay. We will just review the ones that are up to date. So we'll start with knowledge K102, and in this subject, we're actually gonna review two. We're gonna also review knowledge K103 because it's just like this information about indicator flow rate. So we will go over some density input, some steam flow instruments, density compensated, mass flow rate, and the relationship between the flow rate and the differential pressure. So let's get started. So in here, we're gonna have first a steam flow instrument that is gonna look something like this. What do we need to know about steam flow instruments, right? So the steam flow instruments are gonna convert, in GFEs, they're converting volumetric flow rate to mass flow rate, right? So we use this type of steam flow instruments, right? Because we measure the steam flow because we want to get some steam energy information. So this is basically, so when we are trying to compare, a liquid flow, the measuring of the steam flow is gonna be a little challenging to measure because most of the steam flow meters, they measure velocity. Some other they say, okay, they measure flow rate. But in this case, what we're gonna have here is that we're gonna measure velocity, right? We have velocity here. And also we're gonna have the internal area. So since we already know this internal area, and we measure the velocity, we can get the volumetric flow rate, right? We get the volumetric flow rate, and since we know the density, we know the density of the steam. From that information, we can calculate the mass flow rate. So that's why we say that we are converting from volumetric flow rate to mass flow rate. So to accurately measure this, so we have certain requirements, right? We need to measure the temperature. We need to measure the pressure, and we also need to measure the velocity, as we already said. So some of the instruments they're gonna have an orifice here, another here, and they give the information through here. They are single element instruments. I think theirs are called single, but anyway, there is like a multi-variable type of instrument where we have everything in here. It's just one instrument, and these are supposed to be better because we don't have too many holes where we can have some leakage, right? So that's gonna be better. We have less risk of having some orifices here and having some leakage there. So here, what we're trying to measure, the steam. The steam is a compressible fluid, so therefore, if we have a reduction in the pressure, this is gonna result in a reduction of our density, right? So that's why we have those type of instruments. So temperature and pressure in this thing are gonna be dynamic, are gonna be changing, right? So that's why it's important to calibrate the equipment because this can result in a considerable difference between the actual pressure and the meter design parameter. So it's important to, always calibrate this type of equipment. And, to accurately measure this, we need to have this functioning very well. And the temperatures that are associated with steam flow measurement are often quite high because, we're trying to measure steam. And these temperatures, can also affect, the accuracy of, the electronics, of the measuring electronics. So that's why sometimes we have like some tolerances. Also, this can be affected by moisture and impurities from the steam. And, those can cause like, the erosive nature of the steam can cause some damage to the sensing elements as well. So we just need to take those things into consideration, right? But what are the things that we need to know just for GFEs? That for GFEs, volumetric flow rate, we are trying to convert volumetric flow rate to mass flow rate. That's what we're trying to do. And that's all that we need to know for GFEs, right? Everything else is extra information so we can understand like what a steam flow instrument is. So now we have density compensated. So as we already talked, compressible fluids such as gases and steam, they're often going to experience changes in their density. So this volumetric flow rate, they can account for these changes, and they can produce also, an inaccurate flow measurement. So there are some technologies that can measure mass flow directly, and also these ones can have difficulties in metering compressible fluids such as steam. So therefore, having a density compensated mass flow metering is better. Is a better method for compressible fluids. So in density compensated mass flow measurement, temperature and pressure measurements are used to calculate the fluid density. So this fluid density is then combined, as I mentioned, with the volumetric flow rate to calculate mass flow rate. So, we use it for that. So one of the important things to know about GFEs, for instance, we have this what we call density compensated, and for GFEs, the only thing that we really need to know is that the density of the steam is going to be proportional to the pressure of the steam, and that the volumetric flow rate is going to be proportional to the square root of the differential pressure when we are dealing with density compensated instruments. So now we have mass flow rate. So sometimes we're going to be given some information. We're going to be given temperature initial. We're going to be giving temperature final and mass flow rate of the steam initial, right? So we're going to be giving this. If we're giving the temperature, we can get the densities, right? Very easily. And from that, we can calculate our final flow rate. And those are the type of problems that we're going to see at the GFEs. So now, what's the relationship between flow rate and differential pressure? So the only thing that we need to know from GFEs is going to be related to saturated steam, right? So when we have increase on the pressure of the steam, when the pressure of the steam increases, we know that the density of the steam is going to increase. Therefore, the specific volume of the steam is going to decrease. And we can use the steam tables to get this information. And we also going to have venturi flow. So for the venturi flow, we're not going to go in depth into everything, but just a basic understanding of what we need for GFE. So a venturi works by measuring different in pressure in two locations, pressure 1 and pressure 2. So we have those two locations. And the pressure difference is created by reducing this diameter here of a pipe, causing the fluid to flow faster. And the fast moving fluid is going to have a lower pressure than the slower fluid in the larger section of the venturi, right? And that's how we are going to measure the venturi flow. One of the other relationships that we can get, and that's going to be used for GFE, is going to be this one. So density is the inverse of the specific volume. So we can substitute and get this formula to calculate the flow rate of steam. And finally, we're gonna, at GFEs, we're gonna look at the indicated flow rate. And this is just like a formula we can use. We're gonna have the flow rate indicated. It's just gonna be proportional to the square root of the differential pressure. And that equals the square root of the pressure on the high side minus the pressure on the low side. And for this section, that's basically all we need to know. And we might go more in depth into this. But for GFEs, for these two knowledge, that's all that we need to know.